Karen Wu was chosen for her organization skills and her will to do things fast. She can help her crew navigate through space and write information clearly. She's able to work in fast conditions to get things done.
Hani Jen is great with numbers and calculating precisely. Her skills help the team to get accurate calculation in the space mission.
Astronaut Neha K is very fluent in mathematics and writing. She has the ability to resolve conflicts and manage time well, which will prove useful for emergencies.
Sanya Adil can work under pressure and is very calm. She will be helpful in the mission since she can help in emergencies and first aid. The gravitational pull on Saturn is more than Earth's, which means we cannot bring many oxygen tanks. To do this, we will use a device that turns water into oxygen using electrolysis. The International Space Station uses this method of obtaining water. The trip to Saturn is also very long, so we can save oxygen by this process.
Our team will be using the water reclamation system that is aboard the ISS, which collects astronaut wastewater and humidity condensation and purifies it. It will produce a sufficient water supply to last the whole expedition.
Our team will be eating the recommended dietary allowance to have the needed amount of vitamins and nutrients for the expedition, with specific caloric requirements. It will include anything the astronaut prefers, allowing a range of vegetables, fruits, and grain foods that have a specific nutritional content.
We will be using the same gravity assist that Cassini-Huygens used to visit Saturn, the Cassini trajectory or VVEJ gravity assist. Our spacecraft will be using Venus's gravity twice, then Earth's, then Jupiter's. This gravity assist method will allow less consumption of fuel and will boost our spacecraft velocity to arrive at Saturn.
Our space team will not be using FM radio waves to communicate, as the FM radio signal is more local and cannot be transmitted over large areas. We will have large antennas that will transmit signals to the Deep Space Network, the DSN, which supports interplanetary spacecraft missions to communicate with Earth. The communication unit our space team will be using is a conventional AM radio transmitter which will be able to be transmitted over longer distances. We will reuse the panels from the Apollo program for our spacecraft.
Our HVAC units will be mainly solar-powered and built with specific materials to ensure the safety of astronauts. We will be using non-combustible and heat-retaining materials and non-corrosive metals. To maintain our heating technology, we will periodically check the filter in the device for dust, mold, or rust and clean it.
The sun emits 3 types of radiation: UV, visible light, and infrared. When exposed, one can experience health problems with the potential of developing cancer. We will use survey meter to determine if one has radiation poisoning. To curb the damage of the poisoning, we will use potassium iodide pill, especially to protect our thyroid gland, the part of the body that is most susceptible to damage from radiation poisoning.
Some important equipment for this mission to succeed are communication devices like the communication carrier assembly, a hat with a microphone. Another piece of equipment would be a trace gas analyzer, which assesses gas concentration and identifies them. It could be dangerous if there is a leakage of an unknown gas on our spacecraft. It is essential for our safety. Tools such as nails, wrenches, and hammers may be useful in the case a part of the ship needs repairing.
Saturn is the second largest planet in the solar system, and its diameter is 9 times the size of Earth. The diameter of Saturn is approximately 120,535 kilometers, or 74,913 miles. Saturn has a very fast rotational speed, so a day on Saturn is about 10.7 hours, or 642 minutes, or 38,520 seconds.
The distance from Saturn to Earth is always changing due to the orbital speeds of each planet, but the distance can be averaged to 8.52 astronomical units, or 1.275 times 10 to the power of 8 kilometer, or 0.00014 light years. The distance from Saturn to Sun is also always changing as it travels in an elliptic pattern, but averages as 9.5 astronomical units and 1.5 times 10 to the power of 9 kilometer, and is 0.00015 light years.
Saturn's orbital radius is averaged to 1.4 billion kilometer, or 9.5 AU. In the night sky, Saturn is one of the slowest moving planets. Its motion seems to be in a S shape, but this is just a reflection of Earth's movement.
The gravitational pull of Saturn is 10.44 meters per second square, which means that objects on Saturn would weigh about 0.8 pounds more than on Earth. Saturn does not have a surface like Earth, as it is a gas giant, but it may have a core which is composed of metals like nickel and iron. which is covered by liquid hydrogen and liquid helium. Saturn is made mostly of hydrogen and helium.
Saturn goes through all 4 seasons, each of which lasts about 7 years. The temperature on Saturn is averaged at negative 185 Celsius. Saturn does not have a solid surface like Earth and is made up of mostly hydrogen gas and helium, as it is a gas giant. It has one of the fastest wind speed of the solar system, after Neptune, so the weather is very violent.
Saturn has 53 official moons, 9 more exist, but they're unconfirmed, as discovered by Cassini-Huygens spacecraft. Solar eclipses happen frequently since there are many moons. The largest moon, Titan, which has a really salty ocean, equivalent to the saltiest ocean on Earth, has 16 moon phases, the highest one having a bright ring shape around the moon due to the sun rays scattered through the atmosphere.
An asteroid is a small rocky object that gets caught in the sun's orbit. A comet orbits the sun but is made of ice and dust instead of rock. When a meteorite doesn't completely vaporize in Earth's atmosphere, it becomes a meteorite.
Saturn has a massive ring that is made up of ice, dust, and rocks. These chunks of rocks and ice are thought to be pieces of asteroids or comets. Some pieces are very large and others are tiny particles. The rings extend 282,000 kilometers from Saturn, which may prove difficult to land on.
Based on our research, it may not be wise to try to land on Saturn as there is no surface. So our crew decides to build an ISS to orbit Saturn and gather information about it.